Geothermal energy, so tapping the heat in the earth, only is about 1% of U.S. energy right now, but that might be about to change. In the first quarter of 2025, the geothermal kind of sector in North America pulled in $1.7 billion in funding. That's about 85% of what the entire sector saw in 2024, just in one quarter. So that's kind of, to me, a bit of a dramatic signal that investors are looking to invest in geothermal energy and technology. So let me tell you about it. Traditional geothermal works only where you have naturally hot water or steam underground in the pore spaces of the rocks, plus permeable rock to let the fluids flow. And that's why geothermal has been limited to volcanic or tectonically active zones. So you can think about like California and Iceland. Enhanced geothermal systems aim to break free from those constraints. Instead of relying on naturally permeable hot waters, EGS, so the enhanced geothermal systems, drill deeper into hot, dry rock. They fracture it and inject the water and then recover the heated fluid. So you are, in effect, creating your own geothermal reservoir. There are variants too. You have closed loop systems that don't rely on extracting formation fluid, and super hot rock systems that target extremely high temperatures at depth. So let me tell you how EGS works versus conventional systems. So conventional geothermal drills into a naturally hot water reservoir. It brings up that steam or hot fluid and then uses it to drive turbines, and then they re-inject the water back down into the rocks. In enhanced geothermal, they drill into hot, dry rock, create those fracture networks, and inject water through one well, let it heat in the rock, and then extract it from a second well. One major innovation comes from borrowing some techniques from the oil and gas industry, and this is horizontal drilling. They also use controlled fracking, and they combine that with advanced subsurface modeling that folks have been doing for years. So companies like Fervo Energy have been using all those techniques developed over decades in oil and gas and applying them to geothermal energy. Fervo's Cape Station project in Utah is frequently cited as a landmark. In Wood Mackenzie's report, they listed it as a 500 megawatt project with demonstrated performance at about $79 per megawatt hour without any subsidy. They've also reported dramatic improvements in drilling efficiency, a 70% reduction in drilling time from earlier wells, and a drop in horizontal well cost from about $9.4 million to $4.8 million in some cases. So if these trends continue, enhanced geothermal systems can end up creating and unlocking so much more geothermal potential. So using our Earth, what we have all around us, as a potential energy source. So now let's talk about scale and scaling it up and why it matters. The U.S. today has about 4 gigawatts of installed geothermal capacity, but Wood Mackenzie's and others estimate about 500 gigawatts of technical potential using this enhanced or next-gen geothermal in the U.S. alone. The Wood Mackenzie report also claims that geothermal can deliver 15% of global power by 2050 under favorable conditions. Geothermal has a big advantage because it can dispatch clean energy 24/7, whenever we need it. When solar and wind aren't producing, geothermal can fill in that gap. Projects like Cape Station show geothermal may already be entering a cost-competitive zone, which hints at a future where geothermal is not niche, but actually a major grid player. So why is this investment surging now in 2025? First, there's been a bit of de-risking. In the beginning of the year, there were 47 new well announcements. That's up 80% from the year before. Second, real-world projects like Fervo's are really pushing the envelope in terms of the well costs as well as performance, and that's getting noticed worldwide. And then finally, policies and laws that kind of tend to regulate what's going on and what we want to invest our tech in have been loosening up in many jurisdictions, and that's been accelerating the permitting, incentives, and research and development. But we still need to be honest about some of the challenges that we're facing with enhanced geothermal. Deep drilling costs and risks are extremely high. Induced seismicity is a concern when fracturing rock. Permit, regulation, and environmental constraints are often in place, especially around water use and the seismic risk. And you still need to connect to transmission lines, so the location does matter. Even so, the magnitude of investment and the pace of development are suggesting we're past early hype and into the era of real demonstrations and scaling. So we've gone from niche to more of a contested and proven up frontier. With $1.7 billion in Q1 investment and major projects like Fervo's showing real cost metrics, I'm pretty excited about enhanced geothermal. It might be the missing piece for 24/7 electricity for our grid. If it succeeds, it could be a very reliable power in areas further away from volcanoes and other hotspots where we often use geothermal. So what do you think? Are you as excited about enhanced geothermal as I am? Let me know in the comments below.